Hello Internet. Today we're going to be working on what I'm calling a squash shader. So I saw somebody demoing on Twitter, I don't remember who, but they were demoing something. So they had a shader that would deform things as it came into contact with a plane. So we're going to be making a really quick version of that. I think I have an idea of how to solve this. So right now I have a bunch of falling balls, but one of the things you'll notice is that they're actually falling through this plane here. And so the idea is we're going to use a vertex shader, and this is kind of going to be our introduction to vertex shaders. But we're going to use a vertex shader to bend this mesh out when it goes beneath that. So instead of just going through and clipping through, it's actually going to squash down and kind of blow up a little bit, kind of squeeze. And so that's sort of the idea here. We'll have to play around with it because I have no idea how this is going to go. But I thought it would be a fun experimentation, and we haven't done anything with vertex shaders yet. So to start off with, a vertex, there's two things that a shader does. There's the vertex shader, and then there's the fragment shader. So we've been doing mostly surface shaders, and this is still going to be a surface shader. But the surface shader mostly does the fragment side of things. It doesn't do much for your vertex manipulation, mostly because that is a little bit more difficult to manipulate. So what a shader does is, first off, it's going to translate your object into camera space. So like we have these spheres and they're all the same. And so if I pause this, you can see each of these polygons. So you see all of these triangles with all these vertices. All of these vertices are what represent our mesh. And there's a set of like faces that define each of these triangles. So it knows what's connected to what. The difficult part is all of these things, they're all local. So they're all within this single space, and they have no idea where they are in the world or anything like that. So there's a whole chain that things step through. So they go from object space into world space, into camera space, and then there's some other projections and stuff that happen. And we're not really going to cover that, but the thing you need to know is that's what's being handled as the vertex shader. So we don't need to totally mess with this. I'm actually using a quick shader I did that actually has a vertex component in it already. We don't really need to mess with it much, but we will need to mess with it just so that we get an effect. So here's what we have. We have a really simple red ball. I'm using what I'm calling my squashing shader. There's no texture, there's nothing else. So if I open that, this is what we have. And this is more or less the exact same surface shader you get when you go and create a new surface shader from Unity's menu. So all of this code is the exact same. All of this code is the exact same. There's two differences. This little vertex thing here, and then this function. And so how this is working is when you give it a vertex function, this is telling Unity, use this function to generate our vertices, or run this as part of our vertex shader. And it's the second part, that's your name. So we're saying run a vertex shader or vertex function, vert, and we just need to implement that method. And there we go. And then all I'm doing here is a whole lot of nothing. So what this is doing is it's actually multiplying the vertex by its normal and multiplying that by 0. So it's just adding nothing to it. So this doesn't do anything. The cool thing is I can, let's say we tie this to like, just because I want to show this, we'll tie it to the metallic. And ignore this world pose, we'll get to that in a bit. But the idea here is we're going to take our current vertex and we're going to take its normal. So its normal is, well, that just made everything bigger, and it's going to mess with the lighting a little bit. So I'm going to actually bring that down. And so you're seeing a little bit of the surface shader stuff, or the vertex shaders going on. But what a normal is a normal is the angle coming off of that. So like if you look at the top of this cube, its normal is going to be going up off the screen towards the sky. And so it's just telling it what is the direction this is facing. It's like I'm facing that way. That's my normal. And so every single vertex is going to have one of those. And what the shader program is going to do is it's actually going to interpolate between those. And so you'll see it's actually smooth. So each of these vertices is going to have a normal position that's relative to itself. And then that's going to be translated into the world space and eventually camera space and all of that fun stuff. But in between that, they're all interpolated between them. And that's actually handled by the fragment shader. We're not going to get into that. But there's a lot of fun stuff that shaders do that you don't need to worry about that is really cool. If you want to learn more about that, look up barycentric coordinates. That's how a lot of this fun stuff is done. So if you want to know more about that, check that out. I may be able to find something helpful and put that in the description, but I'm not entirely positive about that, so you may have to use your Google foo. Anyway, what we have is we're taking that normal that's pointing directly out of that vertex, and we're just adding it as like a scalar. So if I increase this, our shapes get bigger, and if I decrease it, they get smaller. We're getting a little bit weird stuff. It looks like shading is a little bit funky. And I think that's just because everything is not working as I intended. But if we turn, no, it's still a little bit funky. So we may have to do some custom lighting because we're going to be doing some of this deforming stuff. That's why I had that there, just as kind of a quick example to get us started. So, idea here is I'm going to turn these back on just so we can kind of see what's going on. But the idea here is we want to check if it's below a certain threshold. And if it is, we want to take these vertices and we want to squash it out by the normal, but only on that plane. And to start with, we're just going to be using this plane. And so it's directly on the XZ plane. So we're just looking at the Y vector. And we can just get world position, which is why I have that function in there. And so if we take that, we can actually do some pretty simple stuff to get most of what we need. So let's get started. So the idea here is we've got our world position. What we can do is this is actually going to be our vertices world position. And so this is matrix multiplication. So it's taking our vertex and it is translating that from its local object coordinates using our current transform and actually taking that matrix and multiplying the two. We're not going to get into that either because that is complicated. So there's a whole bunch of, if you are like taking linear algebra or don't want to learn linear algebra, this is sort of something that comes from that. Matrix multiplication is all there. So this is just matrix multiplication, and how it works and why they do it, you'll have to read up on that because we'd be here longer than I want to. I'll probably come back to it, but not yet. So what we have is we have the world position of our vertex. So what we can do is actually, do we want the world position of our normal? We may. For now, I'm not going to do that. And I think that should be fine because we actually already, well, that's not going to help us at all anyway. So I'm going to revert that change. So what we're going to do for now is we're not even going to add any additional plugins at all. We are going to just do a really quick scalar. Let's do sorry. So if our vertex.xyz, and we are going to, let's see, how do we want to do this? We're going to want a float of our squish. And so the squish is going to be our world pose.y, and it's going to be the minimum of our world pose.y and 0. And so how this is going to work is if our world position is negative, then this will give us a value. If it's not, it's going to give us 0. And then, so this is going to give us some sort of factor that we can use to squish our mesh. And so we also want to multiply this by something. I don't know what yet. So actually, let's just keep that. Let's multiply it by something big so this won't look good at all, but we'll know if something happens. One of the difficult parts of shaders is debugging them. And that's just because all of this is happening on your GPU. And at least with like vertex shader or with fragment shaders, it's happening for every single pixel on your screen, and usually multiple times for every pixel on your screen. With vertex shaders, it's happening for every single vertex that this is applied to. So figuring out what's going on can be a little bit difficult, and you don't have like a log or anything that you can write to. Okay, so the idea here, we've got our squish. What we can do then is we want a normalized, vector that is going to be our extension of this. And so since our plane is on the XY or XZ plane, it's just flat, we want to zero out that Y and then get it normalized again. And so how we do that is we're going to take our normal, which is just v to, we'll call it something useful, like normal, that works. And we'll call it v.normal. And then we will take our normal.y, set that equal to 0. And then we'll take our normal equals, I don't think this works. I think that's going to throw an error, so let me check. One way you can do that is just restart it. And Unity should build it, so I think that works. So normalize is going to get us a it's going to get us a length 1 vector for our whatever vector we give it. So this is going to zero it out, so we just get the vector along this plane. And then it's going to normalize it so it has a length of 1. And then what we can do is take our vertex and add the normal times our squish. And I imagine this isn't going to work. And that's because our normal is still in object coordinates. Our normal is based off of how the object is and not how it is in world space. When you're working with vertex stuff, you have to keep that in mind of what space you're working in. If you're working, so going back to like a Unity example, my shader's not compiling, but going back to a Unity example, if I start parenting things to things, so if I make this a parent of the plane, which doesn't really make sense, but the idea is if you look at this position now, it is relative to the plane's position. So if I move this plane, that object moves as well. It's the same idea. And so what happens is if I turn my object, that normal is still the same because I'm not changing its position, I'm changing its position in the world. And so that normal is still going to be referencing the normal in the object space. So we need to get that to the world space in order to work with that. So cannot call a non-function. Well, that's because I typed that wrong. There we go. So one thing I'm going to do is I'm actually going to take this and take our v.normal and actually multiply this out into our object to world and do our v.normal. So this is actually going to get our normal in world space. And then all of our other stuff is going to stay the same. So theoretically, this should work now. We are getting some weird stuff. The tops of our cubes are missing and the bottoms. May have broken things. That's all right. We can work around that. I'm just kind of curious what happens if I drop this down. Ah, so it does work. So if you look, what we haven't had happen is one, our thing is negative, but if you look, we're actually taking, I can drop this plane quick so you can actually see that better, but we're actually squishing our object. It's doing a little bit of this, but that's because this is going to be negative. Our squish is going to be a negative value, and so we just want to take the opposite of that. And there we go. So now we're squishing it. And it looks kind of squished. The only issue now is if you look where our plane is, it doesn't look too squished. I mean, it looks all right, but we have to really squish it, and we're barely getting anything up here. And so part of that is we want to actually extend this up a certain amount above that and actually detect it higher up. And then do sort of a function to kind of smooth this out. And then we also want to clamp the vertex itself to be this. So we've got our vertex being multiplied out, and we also want v.vertex.y equal to the max of v.vertex.y and 0. And we're going to go back and change all these zeros to be better. But what this is doing now is it's clamping it so our vertices never go below 0. If they do, it pulls them back up and sets them to 0. So now we've got this kind of thing. And I don't know why the top is disappearing. We're going to have to figure that out. For now, though, I'm actually going to copy this quick and just do a squish amount. And we'll just call this squish amount. Sure, why not? And we'll make it a float and start it at like 1. And then the other one is going to be a squish limit. And this way it will just be able to move that 0 around and actually work with what we intend. So all I need to do is copy these down here, as we can do halves, sure. So squish amount and our squish limit. So now we have an amount that we can use, which is going to be this. And then we have our limit, which is going to be plugged in here and here, which is going to be our clamps. And now everything should work, and we should be able to actually move this around. And I can pull that out. Cool. So everything should be mostly working except for that missing top, which I don't know what's going. Oh, shoot. I broke it. I had typed an extra A. I think, yep, there we go. So that fixes that. And we get this slightly less awful look. And we can actually kind of adjust this. Make it negative so it does a little in thing. But anyway, it works. It doesn't work. It is very broken. Okay, so it doesn't work. I don't know why. One sec. That's interesting. Squish limit. Well, that's probably what's breaking it. So I imagine what's happening is this vertex is going to be all the way the top and bottom. So its normal is actually going to be only on the Y. And so when we try to move this, it's not really going to have any effect. And it's probably going to throw some sort of error. So we need to fix that. And I don't know how. What's the best way to do that? So for normal, normal.y equals 0. If our normal normalizes to that, well, I don't want to do this. Okay, this is going to be just for quickness. Just so we can kind of prove this out, I'm going to do a quick test. And if they're not equal to either of those, then we'll do this. Which normally in shaders you want to stick away from branching stuff because this is slow. But for now, let's get it working and then we can clean it up later, or you can go through and experiment, because that was causing, I assume what was happening is we were getting some error trying to do this because we were getting we were trying to normalize a 0 vector because we were taking straight up and then setting that to 0 and then trying to make that length 1, which doesn't really make any sense. Imagine you have a point. Where does it point? I have no idea. I don't think anybody does. So now we need to figure out why this is happening. And it looks like we're using object coordinates is what this is looking like. And it is. We're using the vertex position and not the world position we calculated. So we need to fix that. And I'm starting to think this may not work. Yep. So that worked well. So what's happening here is we're totally doing this wrong. And we're plugging in our world position as our current vertex position, which doesn't actually map. And so this needs to be fixed. And the way we can do that is we can actually multiply again. Our unity world to object, I believe. And the max of this. That's not going to work. It's not going to work at all. Because this is, yeah. So we want actually our world position.y. There we go. And then we can take this multiplication out and do it down here. And we'll take our world pose and translate it back into our vertex. Like so. And I believe that will give us what we want. One way to find out. Ooh, doesn't like that. Okay. Extra parenthesis. Okay, getting the feeling this is wrong. Yep. Okay. Usually when you see shadows and stuff floating in the air, you did something wrong. That's a good tip. It'd be nice if I had done this in the past, like, month. Let's see. So that doesn't work. So what we have is we have our world position. And actually, so the difference is going to equal our world pose.y minus our, no, it's going to equal our squash amount, or a squash limit, minus our world pose. So if we're at 0 and our world position is negative, that's going to be a positive difference. That's not what we want. Sorry, this needs to be the opposite. So as you go past our squash limit and keep going down, this is going to get more and more negative, and that makes more sense. So what we get here is, so what I'm trying to do is say we're trying to solve the difference between our squash limit and our world pose, but we only want the minimum value of that, which is going to be our world pose.y minus our squash limit and 0. And then we can take our vertex.y. That's not going to work. So the issue is our difference is not going to be in, actually, yes it is, because, okay, this is going to be weird, but I'm going to multiply this by our difference times a float 3 of the up vector, but we're going to translate this into world space. So we now have a unit vector in world space that we can move our vertices by the difference, right? So we'll move it up that much. I think that makes sense. Apparently it doesn't make sense because we're getting errors. Okay? Why is that? I should have looked at the error. Unidentify. Okay, so that doesn't. Oh. Squish limit, not squash limit. I'm gonna confuse those because I called it a squashing shader and then I called them squish. Whatever. That wasn't what I wanted. This is going well. What have I done? It looks like our difference is always 0 or close to it because we're always setting this to that. Oh. Because we didn't want to multiply, we wanted to add. There we go. Okay, so this looks normal, right? But if I... Oh, I did drop it down. Okay, so it is slowly growing out. It's not really clamping the way I would expect, but we can work with it. So it kind of squishes, and that's sort of what we want. The issue is it's not squishing soon enough. So it's all underground. That doesn't really look that good. And it doesn't... Oh. Oh. What have I done? Oh, I'm moving it up. That's what's happening. What is this? I have created a monster. So it's occurring to me now that you may not have wanted to come to me to learn about shaders because clearly I am very good at them. But so the idea is it kind of melts into that. It should be more squishy. And I don't know why it... I was expecting this not to go under the 0, but it is. And I don't know why that is. So we'll have to play with that some more. Huh. Okay. Why is that? Let's walk through it. So our squish is going to be the amount we're below our squish limit, and that's going to be a positive number. So can we use that as our difference? One sec. The answer there is no. Huh. I mean, kind of works. I mean, this will be interesting. If we play it, watch this. Isn't that cool? It kind of squishes. It looks very, very broken. Okay. So this wasn't entirely what I had in mind, but it seems to be getting there. It may not look like it's getting there, but we actually are kind of getting to a point that it looks all right. I mean, when you give it realistic values, it kind of squishes realistically. The issue is it just doesn't squish in the right place. So what I'm curious about, why does that all happen below our plane? If I drop that down a little bit, why is this like this? It looks like we're not moving our Y position. Like it looks like this isn't doing anything. And I don't know why. So what this was supposed to do is it was supposed to take, well, let's get our difference back, because I think I actually need that. It's supposed to take our difference of our Y beneath our squish limit. Oh. Does that solve it? No. Why not? So this is going to be some negative value of the difference between our world position and our squish limit. So if our squish is up here and we go below it, our difference is going to be negative this value, whatever this value is. So say this is 3. Then we get -3 as the difference here. Plug that in, and now we get a up vector in world space. And we want to subtract that from our vertices. And so I was expecting that to kind of go zoop and lift it up. And the cool thing is it does kind of work. I think it does. Oh. I lied. That may be part of the problem. I think we may have a coordinate mix-up. That's kind of cool, though. It's not right, but it's kind of cool. So that may be our problem. That's actually really cool. It's like a hat or hair or something. All right. Anyway, that's totally not what we're going for. So let's fix that, because that's wrong. What is going on? Well, if I take this out, does that fix it? Then we'll know that was the problem. Part of me is saying no. Okay. So I'm thinking, well, this normal is in world space. I think I may have confused myself with this. What if I just use the normal? Did I just go on that entire rant for no reasonable reason? No, it's broken still, just in a different way. So you see, things act differently in different coordinate spaces, and they look kind of funky doing it. Okay, so I'm gonna fix that. There we go. Go back here. This needs to come back because that was correct. Our normalized function is correct. This doesn't appear to be correct, and I suspect that our squish is calculated wrong, but I don't know how, because we're taking our world position, seeing how far below the y coordinate we are, so if it's that far below, I have a feeling this is going to be even worse. Trying to figure out what is actually going on here. It looks like we're getting like negative numbers, because this is cutting back in and then doing something weird. And that's all kinds of messed up. Okay. This video is starting to run a little bit long, so I don't really want to just leave it here. We've got like some sort of weird, like, I don't know, crew cut? Some sort of weird haircut with like the world's biggest scarf. This has gone poorly. All right. But anyway, vertex shaders are fun. You get to do this stuff. Don't do this stuff because this is wrong, but you know, do this stuff because it's fun. So I'm going to leave this here and we'll pick it up in another video. I don't know where it's going to go, but hopefully better than this. So eventually what we're going to get to is when I drop these. No, that's bad. Okay. But when I drop these, they should squish correctly is the ideal here. And so they should do something like that. Well, not anything like that. Something more like this. Oh, is that part of the problem? Maybe. Yeah, that looks saner. Okay. So it should look something like this, but it should actually work. Anyway, I think that's all I have. So hopefully you guys found this enjoyable. Hopefully you learned something. I clearly am learning things. So if you liked it, let me know what you like in the comments, and hopefully I'll see you guys in the next video. So until then, see you, internet.